Okay, this video is homework help for Unit 2, Assignment 1. We're going to do 2 problems from each grouping. So numbers 4 and 11 will be for the problems numbers 1 through 12, and 15 and 17 will be problems for numbers 13 through 20. This video is not designed to replace notes. So if you have not watched the notes video, you need to go ahead and pause the video, go watch the notes video. That way you're actually learning how to do what we are about to walk through. While I'm going to explain kind of the thought process behind the problem, I'm not going to go in nearly as much depth as I did in the notes video. So again, this is not replacing notes. This is for people who are wanting to check their answers because they've done them already, want to do just a couple more review ones, or maybe who did most of it but got stuck on an element of part C or something like that. Again, not notes. It's to help you check your work, get a little bit extra help in that area. Okay? Okay, so for the 4 and 11 one, we have 3 parts to these problems. Part A says plot the polar coordinate in a polar graph coordinate system. Okay, so we're going to go ahead and start by graphing. Okay, so here's my graph. I'll go ahead and give myself my little polar circles. Sorry. Okay. And then graphing our coordinate point. Reminder with polars that we have our r theta here. So 2 pi over 3 is my theta. So my radial line is going to be at 2 pi over 3. Well, where would 2 pi over 3 be if I graphed that angle? Okay, well that would be in the second quadrant. It's the pi over 3 angle, or the 60-degree angle in the second quadrant. Okay? And then continuing that radial line the reverse direction. Okay, so second quadrant, pi over 3. My r is 3. It's a positive, so I'm going along that radial line. Again, if it was a negative, I'd go the reverse direction, and I'm going 3 out along that radial line. And so my polar coordinate is there. Okay? B says, find 3 additional polar representations of that point between negative 2 pi and 2 pi. Okay, so these are like on your Objective 1 notes, like numbers 5 through 7. Okay, and so we're going to take our r theta here, and we're going to start with using the same r, but either adding or subtracting 2 pi to our theta. In this case, we're going to subtract 2 pi, because if I added 2 pi, it would send me up and over my restricted domain of negative 2 pi to 2 pi. And so this first angle here, radius would be r, theta then is 2 pi over 3 minus 2 pi, which is 2 pi over 3 minus 6 pi over 3, if I found a common denominator, which is negative 4 pi over 3. Okay? Second angle, we take our r, our 3, and we multiply it by a negative. And then our theta, we subtract pi. And so this would be negative 3, 2 pi over 3 minus pi, which is 2 pi over 3 minus 3 pi over 3, which is negative pi over 3. Okay. And then last one, our r times the negative, and then our theta plus pi. So negative times our r, which was 3, so negative 3. 2 pi over 3 plus pi, which is 2 pi over 3 plus 3 pi over 3, which is 5 pi over 3. Okay? And then last but not least, we have part C, which says to convert the the polar coordinates into rectangular coordinates, and so these ones would be the most like the second page of your Objective 1 notes, the ones that are like numbers 8, 9, and 10. Okay, so we've got an r and a theta, so a reminder that x is the same thing as r cosine theta, and y is the same thing as r sine theta. Okay, so my x for this particular problem, my r was 3, my theta was 2 pi over 3. Okay, which is 3 times cosine of 2 pi over 3. 2 pi over 3, what quadrant is that in? Remember, that's the second quadrant, so cosine would be negative. And then the cosine of pi over 3 is 1/2. And 3 times negative 1/2. 3 times negative 1/2 is negative 3/2. Y is r sine theta, so r of 3. Sine of my theta, 2 pi over 3. Again, second quadrant, so sine's positive, and the sine of a pi over 3 angle is root 3 over 2. And so we have 3 root 3 over 2. So our coordinate point, x is negative 3/2, y is 3 root 3 over 2. And again, I recommended as we were working through the notes to always just kind of do a quick, even if it's a quick double check, make sure you're at least in the right quadrant for the xy coordinate you just found. Would xy, roughly speaking, put me where my coordinate already is, over here in the second quadrant? Negative 3/2 is an x, up y, sure enough, would be in the second quadrant. Okay? Okay, number 11. Same thing here. So A, we're going to start with graphing. Okay. So radial line, negative 3 pi over 4. Okay, so negative 3 pi over 4 would be in the third quadrant, right? Negative angle sends me clockwise, so negative 3 pi over 4. It's a 45-degree angle there. And then I'm going negative 5 root 2 as a radius. Now, obviously, with negative 5 root 2, this is definitely going to be an approximation. We don't actually, or at least I should say, I don't know what 5 root 2 is. If you do, fantastic. But I don't know what 5 root 2 is. However, I can approximate it, roughly speaking. So negative tells me I'm going the reverse direction of my radial line, right? So I'm going to be sitting out here on the dotted. And I'm going to be moving whatever 5 root 2 is. Okay? Now, I know 5 root 2 is bigger than 5, right? 5 would be 5 root 1. I know that it's fairly significantly less than 10, because 10 would be 5 times 2 or 5 times root 4. So I'm looking at somewhere between 5 and 10. And root 2 is a little bit closer to the root 1 or 5 side than the root 4 or 10 side of things. And so we're going to be looking at probably around 7. Now, if you wanted to, you could take a moment and actually calculate what 5 root 2 is if you wanted to. Let me go ahead and do that real quick. So 5 root 2 ends up being 7.071. So like we said, kind of around 7. But it doesn't have to be, again, it doesn't have to be perfect. It's a rough approximation. And since I'm going to be going around 7, I'm going to make my circles a little bit on the smaller side here. 2, 3, 4. Whoops, that came a little close. 5, 6, 7. And so we're going to be moving 7 away from my radial line this direction. So we're looking at kind of around there. Right, negative 7. Okay, B, my other coordinate points here. So B, we've got our original R, so negative 5 root 2. And then our theta either plus or minus 2 pi. In this case, we're going to add 2 pi. If I subtracted 2 pi, it would put me much less than negative 2 pi, which is the end of my domain. Okay? Negative 3 pi over 4 plus 2 pi is the same thing as negative 3 pi over 4 plus 8 pi over 4, which is 5 pi over 4. Next up, we have our r times our negative, so the negative 5 root 2 times a negative. and then theta minus pi, which is positive 5 root 2, negative 3 pi over 4 minus pi, negative 3 pi over 4 minus 4 pi over 4, which is negative 7 pi over 4. And then same thing, we have our r times a negative, and then theta plus pi, which is our positive 5 root 2, negative 3 pi over 4 plus pi, negative 3 pi over 4 plus 4 pi over 4, which is pi over 4. And then last but not least, part C, turning into rectangular. So again, we know what x and y are. So x is my r, negative 5 root 2, cosine of my theta, which is negative 5 root 2 times cosine of negative 3 pi over 4. What would that be? Okay, well, negative 3 pi over 4 is in the third quadrant, so cosine would be negative. And this is a pi over 4 angle, so cosine of pi over 4 is root 2 over 2. Negative times a negative is a positive. Root 2 times root 2 is 2. Times 5 is 10. Divided by 2 is 5. Okay. Y, r, negative 5 root 2, sine of my theta, negative 3 pi over 4, which is my r, negative 5 root 2. What is the sine of negative 3 pi over 4? Okay, well, negative 3 pi over 4 again, third quadrant. So sine is negative, and a pi over 4, sine is negative root 2. And so again, same thing, negative times a negative will be a positive. Root 2 times root 2 is 2, times 5 is 10, divided by 2 is 5. So my coordinate point is 5, 5. Double checking that that roughly speaking makes sense. Where would 5, 5 put you if you graphed that rectangular coordinate? Well, 5, 5 would put you right there. Okay, numbers 15 and 17. Okay, so these ones are the second set of problems here where we are again asked to do three things, but this time we're taking rectangular and going into polar. Okay, and so this one is an xy coordinate that we're going to be graphing. So part A, plot the point in the rectangular coordinate system. So we are graphing negative 3, 3. Negative 3 would be left 3. 3 would be up 3. So my coordinate point would be right there. Okay. B, convert the point to a polar coordinate. Okay, well, so for this one, we have our x squared plus y squared equals r squared, and tangent of theta equals y over x. Okay, so x squared, negative 3 squared is 9, plus y squared, 3 squared is 9, equals r squared, which means 18 equals r squared, which means square rooting both sides. R is plus or minus root 18. Or if you were to reduce that, plus or minus 3 root 2 equals r. Okay? Over here we have our tangent theta equals our y over x. So y is 3 over x negative 3. Which means that tangent of theta equals negative 1. Okay, well, what angle measures would give me a tangent of negative 1? Okay, well, the angle that gives me a tangent of 1 is the pi over 4 angle. And then I want tangent to be negative, so I want to be in the second or fourth quadrant, because tangent is positive in the first and third. So what are the pi over 4 angles in the second or fourth quadrant? Well, in the second quadrant, it's 3 pi over 4. In the fourth, it's 7 pi over 4. And then you have their respective negative names, right? If I subtracted 2 pi from those, I would get the negative value, or I should say a coterminal angle, right? Negative. So 3 pi over 4, if I subtracted 2 pi over from that, it would be negative 5 pi over 4. That would put me also in the second quadrant. And subtracting 2 pi from this one would be negative pi over 4, which would also put me in the fourth quadrant. Okay, and so then you can pick whichever one you want. I'm going to go ahead and use the 3 pi over 4 because we wrote that one down first. Goodness. Remember r theta. Theta always goes second. I did that several times in the notes as well. Okay, 3 pi over 4. And so our r here, we want to end up in the right coordinate point. Our coordinate point's here, so where would this radial line be? Well, 3 pi over 4 is in the third quadrant, right? And so what kind of r would I want so that I landed here for that radial line? Well, since that point is on my 3 pi over 4 radial line, I want a positive r. A negative r would send me the reverse direction along the dotted line. A negative r would put me down in the fourth quadrant, not the second quadrant. And so I want a positive r here, so I'm going to use the positive root 18 or positive 3 root 2. Okay? And then part C says find 3 additional polar coordinates for the point between negative 2 pi and 2 pi. And so you could repeat the process kind of like what we did up here if you wanted to find your other 3 points, and you could do that on the 3 root 2 and 3 pi over 4. Or you actually know what the other 3 points are because you have them all written here. We already used the 3 pi over 4, so the other 3 are going to be 7 pi over 4, negative pi over 4, and negative 5 pi over 4. Okay, so let's do the negative 5 pi over 4 first. What would be its radial line? Well, its radial line is the same thing as 3 pi over 4, so same as what we've got here, so we'd want to use the same r. Okay, next up our 7 pi over 4. What would be its radial line? Well, 7 pi over 4 has the reverse radial line. 7 pi over 4 is in the fourth quadrant. And so to have my point end up in the second quadrant with my 7 pi over 4 being in the fourth quadrant, I want a negative r so that I move away from that 7 pi over 4. So I'm going to use the negative root 18 or the negative 3 root 2. And then last but not least, our negative pi over 4 has the same radial line as 7 pi over 4, and so we'll need the same radius as 7 pi over 4. Okay. And then last but not least, number 17. Starting us off, we have graphing for negative 4 root 3. If I were to graph that. 4, 1, 2, 3, 4. Negative 4 root 3. Don't know exactly what that is, but again, we can approximate it. We know it's definitely larger than 4, or in this case, negative 4, because 4 would be 4 times root 1. We know it's definitely smaller than 8, because 8 would be 4 times 2, or 4 times root 4. And we know that it's closer to the 8 side of things than the 4 side of things, right? And so we're looking at around 6.5, 7, or in this case, negative 6.5, negative 7, somewhere in that range. If you wanted to, again, you could calculate it exactly. 4 times root 3 is 6.9, so closer to the 7 side of things than the 6.5. And again, it would be negative. So 1, 2, 3, 4, 5, 6, 7. So we're looking at down here. Okay. B. I'm not going to rewrite these relationships again. We've got them already. So my x squared, 4 squared is 16, plus my y squared. 4 root 3 squared is 16 times 3, which is 48. 16 plus 48 is 64. And so r, square rooting both sides, is plus or minus 8. Okay, tangent theta is y over x, so negative 4 root 3 over 4. which reduces, the 4's cancel, to negative root 3. So what angle gives me a tangent of negative root 3? Okay, well the angle that gives me a tangent of root 3 is pi over 3. And so I want the pi over 3 angle in the second and fourth quadrant because tangent has to be negative. And so in the second quadrant, the pi over 3 angle is 2 pi over 3. In the fourth quadrant, it's 5 pi over 3. And then their respective negatives, subtracting 2 pi, this would be negative 4 pi over 3 and negative pi over 3. Okay. So first coordinate point, you can use whichever one you want. I'm going to use the 2 pi over 3. Okay, so what kind of r would we want for 2 pi over 3? Well, 2 pi over 3 would be in the second quadrant. And I want my coordinate point to end up down here in the fourth quadrant. So I need to have a negative r, because if I have a positive r, it'll put me up here in the second quadrant. I want a negative r down here. And so we're going to do negative 8. And then last but not least, my other three angles. We use the 2 pi over 3, so we've got the 5 pi over 3 next. 5 pi over 3 has the fourth quadrant radial line. And so I'm going to want a positive r to get me to go into the fourth quadrant. So it's going to be positive 8. We have negative 4 pi over 3, which is the same as 2 pi over 3. So they have that red radial line, so I want a negative r. And negative pi over 3, which is the same thing as 5 pi over 3, that blue radial line. And so we want a positive r. Okay. If you have any other questions, remember there is an extra practice video if you'd like to do some extra practice with some of these concepts from Objective 1, or feel free to reach out to your teacher. We are here to support you.